Okay, Assalamualaikum dan salam sejahtera. Okay, so now we still focus chapter 2. Okay, second order system. So in this case, we only focus for under dam. Okay, so you must know what is the under dam. Okay, so first kita tahu dia punya criteria for the ratio. Okay, this one. Okay, so this one, the ratio between 0 and 1. Okay. Okay, this one we call is under dam. Under dam. Okay, under dam system. Okay, and then macam mana dia punya pole? Okay, so pole basically kita ada okay, this one kita ada real axis and then kita ada J omega. Okay. Okay, so dia punya pole dia dekat sini. Okay, so ada two pole. Okay, two pole complex. Okay. So and then so dah tahu dia punya pole and then dah tahu dia punya depth ratio. So you can get the output equation. Okay, so this one. Okay, this one is output. Okay, how to get this one? You just take in partial and then inverse Laplace. Okay, and then from here you can see the different depth ratio give a different response. Okay, for example, okay, this one lambda equals 0.1. So you can see this one is a excessive overshoot. Okay, this is maybe something like damper, typical dam. Okay, or over dam. Okay, so in this case, we want to know the relationship. We want to know what is a TP here and then TS, and then another one is a percent overshoot. Okay, so in this case, okay, so the first one is a rise time. Okay, TR. Okay, so we want to know what is the TR. Okay, so TR is the time required for the waveform to go from 0.1 of the final value to 0.9. So you can see here, okay, 0.1 to 0.9 of final value. Okay, and then this one we call as a TR. And then for the peak time, okay, peak time you just take in here, okay, is the maximum peak. Okay, so this one we call is a TP. Okay, and then percent overshoot. Okay, percent overshoot is here. Okay, from the maximum, okay, to the final one. Okay, so this one is we call as a percent overshoot. Okay, so basically percent overshoot we express in terms of percentage. So that's why the equation must multiply by 100. Okay, for the last one is a settling time. Okay, settling time is here. Okay, so settling time is the time required for the transient time oscillation to reach and stay within plus minus 2% of the steady state value. Okay, so you can see, okay, so plus minus. Okay, this one is a final value, and then settling time happen between plus minus of final value. Okay, so maybe it's something like 0.98 or 1.02. Okay, so this one we call as settling time. Okay, so next we want to know what is a TP. What the equation? What is how to calculate TP? How to calculate percent overshoot? Okay, so this one is overshoot. So salah je kat sini, shoot. Okay, so for the peak time, Tp, you can use the equation of pi divided by omega n multiply square root of 1 minus lambda square. Okay, or you can use this one, pi divided by omega d. So here you know that omega d is omega n multiply square root of 1 minus lambda square. Okay. And then for the next one is a percent overshoot. So to calculate the percent overshoot, you use this equation. Okay. Percent overshoot equal E exponent. Okay, exponent E minus lambda multiply pi divided by 1 minus omega 2 square root. Okay, and then you can see also E equal minus, this one is a sigma, this one is a okay. And then this one to calculate lambda. Okay, so you can use this one. Okay. Okay, and then for this one you want to calculate TS. Okay, so TS basically the general equation for TS, this one. Okay, TS equal 4 divided by lambda omega n. So omega lambda omega n is this one. Okay. Sigma. Okay, so here you have two equations. Either you want to use 2% and 5%. But for 5% you can use, okay, you can use this one. Okay, 3 divided by sigma. Okay, but it's a depend on the question. But if in the problem is not state any criterion, you need to use this one. Okay, and then last one is a rise time. To calculate rise time, you need to understand this figure. Okay, so here is omega n, and then this one is a sigma, same equal to lambda omega n, and then this one is a omega d. Okay. So Ti equal 1 over omega d, tangent inverse multiply omega d divided by minus sigma. Okay, and then simplify, you can get pi minus theta divided by omega d. Okay, so you must know what is a theta here, and then divided by omega d. Basically, you need to convert this one in radian. Okay. The important thing here, we want to find the group response. Okay, so for a desirable Tarzan response of a second order system, okay, the depth ratio must be between 0.4 and 0.8. If depth ratio less than 0.4, what happen to the system? Okay, the system will be the overshoot will access. Okay, and then for the lambda or depth ratio greater than 0.8, so you can see the response will be like this. Okay, and then here, okay, you want to know the to know the relationship between maximum overshoot and rise time. Okay, so here you can see one of the fact is if one of them is made smaller, so the other necessarily become larger. Okay, for a small value of Ti, omega d must be large. Okay, because you know that Ti equal pi minus theta, okay, divided by omega d. So meaning that this one is small, okay, omega d is a greater because the relationship. Okay, and then comparison between maximum overshoot and then setting time. Okay, so if you want to make the settle time is small and then the maximum overshoot is small, so you need to ataupun you make sure the depth ratio is small too, but it's not too small. Okay, so in this example, in this slide, we have a 4 example. So you can find out, okay, because you can try because all the solution are there. Okay, so I try within 5 minutes more to solve for this one. Okay, so here you have this one. Okay, continue. So, okay, so to find the depth ratio, okay, first you need to find the theta here because for depth ratio you can use the equation. Okay, cos theta equal depth ratio multiply omega n divided by omega n. Okay, so here is omega n. Okay, omega n, and then this one is omega the ratio multiply omega n. Okay, so you can get the ratio. Okay, so to find that you can use theta tangent theta equal 1 divided by 7 divided by 3. Okay, you inverse this one, you can get theta equal 66.8, and then you just put theta, okay, cos 66.8, and then you can get 0.394. Okay, so that we want to find omega n. So omega n here, okay, so you know that this one is omega n and that this one is lambda omega n. Okay, so you can find omega n by using the theorem of Pythagoras. Okay, so 7 square plus 3 square and then square root, and then you can get 7.62. Okay, and then the next, okay, you want to find peak time. So I just focus, this one, okay, because no time, okay, on. Okay, so TP equal pi divided by omega D. So omega D you can take from the graph, okay. So you just get TP equals 0.449 seconds. And then for the percent overshoot, okay, you know that the depth ratio is 0.394, and then you just put here, and then you can get 26. Okay, you just push off. Okay, you just taking your calculator and calculate. And then that's why you for the setting time, okay, we can use the equation for divided by sigma d. Okay, and then you can get, okay, sigma d equal 3, so you just put 1.3 and then you can get the answer 1.33 second, and then you can draw the graph. Okay, you can draw the graph for the system. Okay, something like this. Okay, okay, something like this. Okay, this one is a TP. Okay, TP, you can calculate this one. Okay, and then you can calculate this one is a maximum overshoot. Okay, MP. Okay, okay, and then you can find T apa? Okay, TP and then TS. Okay, TS maybe here. Okay, so something like this lah. Maybe TS here. Okay, so you can draw properly. Okay, compare saya punya. Okay, I think that's all. Okay, sebab tak ada masa dah untuk video ni. Okay, so, okay, and then you can, hopefully you can understand the concept of second order. Okay, so the other 3 example I will show to you how to solve, but solution are there. Okay, thank you.